The Specialty Coffee Association has specific standards for the water used to brew coffee to assure a superior quality extraction of coffee solids. But how do you get to water which meets those standards? Hey, coffee lovers, Mark here from Whole Latte Love. Today, a relatively simple way to make water that meets the SCA standards. If you'd like to learn more about the Specialty Coffee Association standards, use a link up here for my video that breaks down water parameters and how each affects coffee brewing. So, how do you make water? Well, if you know chemistry, you combine hydrogen and oxygen and you get the H2O. But for making coffee, that's only part of the equation. What I'll show you how to do today is remineralize pure distilled or reverse osmosis water to create a brew water that falls within the SCA standard acceptable ranges. Now, again, this is a simplified method that does not require scales, exotic or expensive chemicals, or specialized equipment. In fact, everything you need you may already have, or it's all available at low cost in most any grocery store. Now, I want to reiterate, this is basic level water quality manipulation. It will get you water that falls within the SCA spec, but believe me, it can get much more complex with more specialized equipment and additional additives. So, what do you need? Well, really pretty simple stuff. 2 gallons of distilled water, baking soda, Epsom salt, 2 empty 1-liter containers, a teaspoon and half teaspoon measure, a funnel perhaps, and something to measure milliliters. For that, I'm using a Rattleware shot pitcher. At my grocery store, the distilled water is 89 cents a gallon, baking soda was 99 cents, and the Epsom salt was $2.99. Down the road, beyond the distilled water, the Epsom salt and baking soda cost is less than 1 cent per gallon of water made. So for me going forward, I can make a gallon of water for less than 90 cents. So here we go. To start, fill each 1-liter container with a liter of distilled water. You can eye it, measure it, or if you have a scale, weigh it with 1 liter being equal to 1,000 grams. Then label 1 bottle magnesium hardness and label the other alkalinity buffer. These bottles will contain concentrates we'll use to dose our gallon of water. Now, I know I'm mixing metric and imperial measurements, but don't worry. If your distilled water comes in metric containers, in a minute, I'll have a chart with dosing measurements for those as well. To the alkalinity buffer bottle, add a half teaspoon of baking soda. Put the cap on and shake to mix. The baking soda is actually sodium bicarbonate and will dissolve very easily. Be sure you're using baking soda and not baking powder. To the magnesium hardness bottle, add 2 1/4 teaspoons of the Epsom salt. I don't have a 1/4 teaspoon measure, so I'm estimating a bit using the half teaspoon. When it's all in, cap and shake. It may take a little shaking and mixing to get it all to dissolve. Epsom salt is magnesium sulfate and is providing the minerals for our water in the form of magnesium. The 1 liter concentrate of magnesium, that's going to be enough to dose about 15 gallons of brew water, and the alkalinity buffer concentrate will dose about 5 gallons. The next step is to open the gallon of distilled water and pour off 1 cup or 250 milliliters. That is about how much of the 2-part concentrates I'll be adding back in. Then to the distilled water, add 63 milliliters of the magnesium hardness concentrate, and then add 185 milliliters of the alkalinity buffer concentrate. Using my Rattleware shot glass, I'm filling 3 times to the 50 ml line, and then another 35 mLs to get to 185. With those in, put the cap on, give it a shake to mix, and you're done. Now, here's a chart with those measurements again, including those for making into distilled water that comes in liters. Just always remember to pour off an amount of distilled water equal to the amount of concentrates you will be adding back in. And don't worry if you're off by a milliliter or 2 with the concentrates, you will still be well within the SCA acceptable ranges. Now, if you want to be super accurate and you have a gram scale, you can weigh the concentrates. The metric system makes that easy with 1 milliliter equal to 1 gram for our purposes. Now, again, this is a simplified start at water chemistry manipulation, something that's easy to do at home with commonly available supplies. In future videos, I'll get a whole lot more technical, taking a look at how to vary the two-part concentrations to create water for different brewing methods and using different additives. Beyond that, I'll take a look at tools like the Langelier Saturation Index to appraise water chemistry for boiler scale and corrosion potential. As always, use those comments if you have any questions, and I'll be sure to get you the answers. I'm Mark, thanks for watching, and I hope to have you back soon for more of the good stuff on Everything Coffee, brought to you by Whole Latte Love. Want to learn more? Subscribe now so you'll know about the latest videos on Everything Coffee from Whole Latte Love.